Tensions in the Persian Gulf represent a clash between a global expeditionary superpower and a specialized regional asymmetric fortress power. The United States relies on power projection through carrier strike crews, while Iran focuses on anti-access and area denial strategies. Geopolitics dictates this friction, as 1/5 of the world's daily oil consumption passes through the narrow, high-risk Hormuz choke point. Understanding this conflict requires looking past raw numbers to the specific engineering and doctrines governing both modern military machines. Welcome to K.L WAR FRONT. Today we analyze the technical reality of a US and Iran conventional confrontation.
The U.S. military operates on a budget exceeding $800 billion, emphasizing high-tech.
Conversely, Iran's strategy is born of necessity, utilizing domestic reverse engineering and swarm tactics to offset technological gaps with quantity.
Can high-altitude stealth defeat low-cost, high-volume saturation? This is the fundamental question of modern Middle Eastern technical warfare.
The U.S. Central Command maintains a permanent footprint in the region, utilizing bases in Qatar, Bahrain, and the Emirates. Iran counters this with an underground missile city network, burying their primary strike capabilities deep within reinforced mountain silos. This geographical reality creates a home field advantage for Iran, forcing U.S. forces to operate within narrow, contested waters. The U.S. Navy's Fifth Fleet is the primary shield, but it faces an environment saturated with sea-skimming cruise missiles. Iran's Islamic Revolutionary Guard Corps controls the coast, operating independently from the regular army to maximize unconventional tactical flexibility.
If conflict erupts, the first 60 minutes would involve a massive electronic warfare struggle to blind regional sensors.
Doctrine favors decisive force, aiming to dismantle Iranian command and control within the first phase of operations.
Iran's Mosaic defense doctrine assumes communication loss, empowering local commanders to act autonomously against any approaching foreign assets. But what happens when a billion-dollar stealth fighter meets a $1,000 suicide drone in a congested battle space? The technical disparity is vast, yet the cost-exchange ratio often favors the cheaper, more numerous Iranian weapon systems. To analyze the outcome, we must first break down the battlefield context of the Persian Gulf's unique terrain.
This is not a war of lines on a map, but a war of sensors, ranges, and attrition.
The Persian Gulf is a shallow, cramped bathtub, severely limiting the maneuverability of large nuclear-powered aircraft carriers.
Submarine operations are also hampered by salinity and temperature layers, making acoustic detection difficult and unpredictable for sonar.
Pattern interrupt. Did you know the Strait of Hormuz is so narrow that ships are always in range of shore artillery?
Iran utilizes thousands of sea mines, both smart and moored, to create lethal transit corridors that slow naval intervention. Clearing these mines requires dedicated U.S. minesweepers, which are slow, lightly armed, and highly vulnerable to coastal fire. U.S. air superiority faces a dense integrated air defense system, featuring both Russian S-300s and indigenous Bavar 373 batteries. These systems are mobile, using shoot-and-scoot tactics to avoid detection by U.S. SAD, suppression of enemy air defenses.
Combat in this region is defined by the first salvo advantage. Whoever fires first may overwhelm the opponent's defenses.
U.S. bases in the region are within reach of Iran's short and medium-range ballistic missiles. like the Fateh 110.
The U.S. counters with Patriot and THAAD batteries, forming a multi-layered shield over critical infrastructure and personnel.
However, missile defense is a game of probability. Intercepting a saturation strike requires a nearly perfect success rate. Iran's topography, dominated by the Zagros Mountains, provides a natural radar shield for low-flying cruise missiles and drones. U.S. AWACS and Global Hawk drones must fly high and far back to stay outside the engagement envelopes. The maritime environment is further complicated by hundreds of civilian vessels, creating a cluttered radar environment. Distinguishing a fast-moving suicide boat from a civilian jet ski is a challenge that must be solved in seconds. U.S. rules of engagement are strict, whereas Iran may use civilian shielding to complicate U.S. targeting decisions.
This asymmetry forces the U.S. to use expensive precision-guided munitions for every target to minimize collateral damage.
Logistic chains for the U.S. stretch across the Atlantic and Indian Oceans, making sustainment a massive, vulnerable undertaking. Iran's logistics are internal, utilizing a vast network of tunnels and hardened roads that are difficult to sever. The result is a battlefield where the U.S. has the technological edge, but Iran holds the environmental initiative. Let's examine the U.S. centerpiece, the F-35 Lightning II. Its primary weapon is not its missiles, but its sensors.
The APG-81 AES radar allows the pilot to track dozens of targets without the enemy even knowing they are painted.
In contrast, Iran's Karar tank and Zulfikar missile systems prioritize ruggedness and ease of mass production over stealth.
The U.S. Navy's AEGIS combat system is the world's premier naval defense. Pattern interrupt. Can the AEGIS system handle a swarm of 500 low-cost drones? Current tests suggest saturation is the biggest threat. Iran's Hoveze cruise missile is a 1-1 replica of the Soviet K-55, capable of striking targets 1,350.
These missiles use TERCOM, terrain contour matching, to fly low and hug the ground, avoiding traditional radar detection.
To counter this, the U.S. uses E-2D Hawkeye aircraft to provide over-the-horizon targeting for ship-based missiles.
Communication is the U.S. military's greatest strength, but also its potential Achilles heel if satellites are targeted.
Iran has invested heavily in GPS jamming and spoofing technology, aiming to lead U.S. drones off course or into the sea.
The U.S. AGM-158C LRASM is an autonomous anti-ship missile.
It uses AI to distinguish a warship from a tanker, making it a lethal threat to the Iranian Navy. On the Iranian side, the Khalij Fars is a supersonic anti-ship ballistic missile, reaching speeds of Mach 3. Its high speed reduces the reaction time for U.S. defenses to less than 30 seconds from launch to impact. U.S. Cyber Command would likely target Iran's power grid and fuel distribution to paralyze their domestic response. Iran's cyber units are equally active, targeting U.S. private infrastructure and logistics networks to create domestic pressure. The M1A2 Abrams tank remains the king of the desert, but its weight makes it a logistical nightmare to transport.
Iran's anti-tank guided missiles, like the Delavia, a Cornet clone, are specifically designed to penetrate heavy Western armor.
This cat and mouse game of engineering defines every piece of hardware deployed in the Middle Eastern theater.
However, hardware is only as good as the personnel operating it and the conditions they face.
Chapter 4: Combat Reality and Limits.
In a real conflict, the fog of war would be exacerbated by the sheer density of electronic jamming from both sides.
U.S. forces would face levee attacks, hundreds of small explosive boats attempting to breach a ship's defense.
K.L guns can fire 4,500 rounds per minute, but they can only engage one target at a time.
Pattern interrupt. If a single explosive boat gets through, it could cause damage similar to the USS Cole in 2000.
Iranian pilots, though flying older F-4 and F-14 aircraft, are highly trained in mountain masking and low-level flight. Their goal is not to win a dogfight, but to launch a single missile before being shot down.
U.S. aircraft carriers are protected by burbles, layers of aircraft and ships, but these are visible from space. Iran's Noor anti-ship missiles can be launched from the back of a standard civilian truck, hiding in plain sight.
This makes target identification nearly impossible for U.S. pilots until the moment the missile is launched.
The U.S. Air Force would utilize B-2 Spirit stealth bombers to strike high-value targets deep inside Iran from Missouri. These bombers would be supported by a massive fleet of aerial tankers, creating a vulnerable air bridge. If Iran can target the tankers, the U.S. fighters lose their reach and are forced to land at compromised bases. Urban warfare in cities like Tehran would be a nightmare for any invading force, favoring the local defenders.
Iran's Basij militia provides a reserve force of millions, capable of sustained guerrilla warfare even if the government falls. For the U.S., the primary limit is political will and the high cost of a protracted conflict in the region. A single lost carrier would represent a catastrophic loss of over 5,000 personnel and a $13 billion asset. Iran's limit is its economy, which is already strained by sanctions and cannot survive a total naval blockade.
Modern war is not just about who has the best gun, but who can keep their economy functioning the longest. Technical reality suggests a U.S. victory in the air, but a bloody, undecided stalemate on the ground and sea.
This balance of terror is what has prevented an all-out war for the last 4 decades. Chapter 5: Strategic Value and Future Impact.
The future of this rivalry lies in the integration of artificial intelligence and autonomous swarm robotics. The U.S. is developing Replicator, a program designed to field thousands of cheap, expendable drones to counter Iran's quantity.
Iran is countering with loitering munitions that can stay airborne for hours, waiting for a target to emerge.
Laser defense systems, like the U.S. Helios, are being installed on ships to provide infinite ammunition against drones.
Pattern interrupt. Can a laser work in a sandstorm? Dust particles scatter light, making chemical lasers less effective in the Gulf. This forces the U.S. to maintain traditional kinetic defenses alongside high-tech energy weapons.
Iran's space program, although rudimentary, allows them to launch surveillance satellites to track U.S. fleet movements.
While not as precise as U.S. satellites, they provide enough data to coordinate long-range ballistic missile strikes.
The diplomatic dimension remains a critical weapon, with both nations seeking to influence regional allies. A shift in Saudi or Israeli policy can instantly change the tactical requirements for U.S. forces in the region. Ultimately, the U.S. is transitioning its focus to the Pacific, leaving the Middle East in a state of managed instability. Iran is filling this vacuum by exporting its drone technology to global conflicts, testing its hardware in real-world scenarios. This global testing ground allows Iran to refine its guidance systems and electronic countermeasures.
For the U.S., the challenge is maintaining a high-tech edge while reducing the cost per intercept.
Next decade will see the Persian Gulf become the most sensor-dense environment on the planet.
Every movement, from a submarine to a supply truck, will be tracked by multiple layers of AI. The winner will not be the one with the biggest bomb, but the one with the fastest data processing.
As we have seen, the US and Iran are locked in a technical stalemate that evolves every single day.
Both sides know the cost of miscalculation is too high, yet both continue to sharpen their blades.
This concludes our deep dive into the systems and strategies of the US and Iranian military confrontation. Whether through stealth or through swarms, the future of warfare is being written in these contested waters today.
Precision, range, and cost. These are the three pillars that will determine the next chapter of history.
We must remember that behind every system analyzed, there are thousands of lives and decades of engineering.
The technical disparity remains high, but the tactical gap is closing through unconventional innovation and asymmetric thinking.
Thank you for joining us at K.L. War Front. Your support helps us bring more technical analysis.
What system should we analyze next? The hypersonic race or the future of underwater drone warfare?
Leave your thoughts in the comments below. We read every technical debate and suggestion from our viewers.
Stay sharp, stay informed, and always look past the headlines to the engineering and doctrine underneath.
Join our community to access exclusive deep dive reports and high-resolution technical diagrams of modern weapons.
K.L. War Front, where strategy meets reality. See you in the next mission.